Chapter 1, Introduction and Basic Concepts. All right, everyone, today we're going to start talking about something super important, but I'll make it simple like telling a fun story. Imagine you are surrounded by energy all the time. You can feel it when you eat your food and run, or when you switch on a light. Thermodynamics is like the science that helps us understand how energy moves around and changes form. Just like how we can't create magic from nothing, energy can't just appear or disappear. It only moves or changes its costume. That's what we call the first law of thermodynamics. Now, think about your hot cup of noodles. You know how it cools down after a while? That's the second law of thermodynamics. It tells us energy likes to go from hot things to cold things, just like how your noodles lose heat to the air and get cold. It never works the other way around on its own. You might wonder, where do I see thermodynamics in real life? Well, everywhere. Your air conditioner, your car engine, your body. All of them are little examples of energy moving around, keeping things running. We also use units to talk about things in science, just like we use kilograms to measure weight and meters to measure height. We use Kelvin to measure temperature, joules to measure energy, and seconds to measure time. There are two systems. One is the metric system, which most of the world uses, and another is the English system, which uses pounds and feet. But don't worry, we'll mostly use the metric system because it's simpler. Everything is based on 10. Sometimes people get confused between mass and weight. Mass is how much stuff something has, like how much rice you put in your bowl. Weight is how much the Earth pulls on it, which can change if you go to the moon. So your mass stays the same, but your weight becomes less on the moon. When we study thermodynamics, we like to pick something to focus on, and we call it a system. Imagine drawing a box around your noodles or your hot chocolate. Everything inside the box is your system, and everything outside is the surroundings. We can have closed boxes where no stuff can go in or out, but heat can sneak in and out. Or we can have open boxes where stuff like water or air can come and go. Every system has things we can measure, like temperature, pressure, volume, and mass. These are called properties. Some properties don't care about the size of your system, like temperature. Others, like total mass or total volume, change if you have more or less stuff. Now let's talk about density. It's like how tightly you can pack your rice in a bowl. If you have more rice in a small bowl, it's dense. Specific gravity is like comparing how heavy your drink is to water. Water has a specific gravity of 1, so if your juice has 0.8, it's lighter and will float. Then there's this idea of state. It just means how your system is behaving right now. Is it hot? Is it under pressure? Is it big or small? If even one thing changes, the state changes. And when everything inside the box is balanced, like when your soup stops steaming and is the same temperature all around, we say it's in equilibrium. When things change, like when your tea cools down, we call that a process. If you heat it again and it comes back to the same hot temperature, we call it a cycle. And if it's happening slowly, step by step, it's a quasi-equilibrium process, which is the easiest to study. Finally, let's talk about temperature. You already know hot and cold from your senses, but we use numbers to make it clear. If you touch metal and wood, they feel different, but a thermometer will tell you exactly what temperature they are. We use scales like Celsius, Fahrenheit, Kelvin, and Rankine to talk about temperature. Kelvin is super special because it starts from absolute zero, the coldest possible place where everything stops moving. So thermodynamics is like learning the magic rules of energy, and once you understand it, you can explain everything from cooking to rocket ships. Easy, right? That's enough for today. Next time, we'll dive deeper with fun examples like engines and ice cream.